Maybe we should start on the Polylith topic.
Shall we?
I don't know. Yeah, which of the two? There were two things. Maybe Sean has a opinion on it, but there were two things. One I thought was looking at the book, the Git book, and the other one was the what is it called? The real world example, or
yeah.
So those are the two that looked. Perhaps we should look at, but I.
Let me see. Yeah, the real world example is an interesting repo. But depending on what you want to get out of this, there's the high level documentation, which is in the Git book, which talks about the concepts, and then there's the tool itself. And the documentation for the tool itself is literally like a book. I mean, it's a huge amount of stuff. I'm just thinking, and now they've broken it up into sections. It's, yeah, because there's all the install sections. And then you get a deeper dive into the architecture, which sort of assumes that you already have the tools installed. So we could certainly go through the tool stuff, because it does have examples of how everything works with the workspace and the components and the development project idea and so on. Has anyone worked with Polylith so far?
Not really. I've just made some attempts at it and never. In fact, that's one of the things that I'd like to understand is out of this is to see what benefits does it provide. But I have, from my little forays into it, it seems like I would have to actually do a project and go through it myself first before I got the benefits, or at least even understood the benefits from it.
Yeah, it's a tricky one. I mean, I watched the early presentation from the Polylith team and read the book and started reading about the tools, and I was very skeptical. And I grilled them at length, and I was kind of brutal and a bit rude to the team, to be honest, because I just couldn't understand what it was that Polylith offered. And it really did take until I sat down and I actually built something with Polylith before I really understood it. And when I see people coming new to Polylith, the first thing that they tend to say is, seems like a lot of ceremony and boilerplate and repetition in this. Why am I doing all of this to get the benefits? And the answer is pretty much always, well, yeah, you kind of have to do it and then you'll see what the benefits are. And when you first start needing incremental testing or different project dependencies or different component implementations, all with tool support, then you'll really see the benefits. And it is a pretty hard sell unless someone is coming to it looking for, oh, I know I'm going to be building multiple projects out of a big mono repo. Is there a good way to organize things? But it is a lot more than just an organization of code.
So would it be fair to say that you would need to have the tools in order to gain the benefits? I mean, you can't, it's not just an organizational principle that you could use with tools depths or something like that.
You could. And in fact, Polylith could be, you could write Polylith structured repos for any language. There's no specific reason why it's tied to Clojure. It just happens that that's the language they support in the tool. But you could follow a very similar pattern in almost any language. But the tool does give you a lot of leverage because the tool can check the consistency of your code in terms of dependencies. It can check that you're following the patterns. It can highlight things that are missing that you haven't got set up in one or more of the projects. It can provide you with analysis of what's going to get tested, what's changed since the last build, what's changed since any particular time in history, because it has a bunch of stuff built on Git. So that's how you get the incremental testing. It can provide a full cross-reference of how every component ultimately depends on everything else, what libraries everything uses, what third-party libraries. It now has pluggable test runners, so you can use it with either the Cognitech test runner, which is the original default, or Clojure, which I haven't used, but the Clojure folks, anyone who uses it seems to love it. And now Polylith lets you do that. So yeah, the tool is very useful. And because we're migrating to Polylith at work, we have about 125,000 lines of code total, and currently about 43,000 lines of it has been migrated to Polylith. And so our CI has used the poly test tool, and it's an incremental testing runner. And so, sometimes the CI only takes like 10 seconds on that piece because nothing's changed within any of the Polylith code that needs retesting. And obviously our legacy stuff, we don't have that. So we still test a lot more things in our legacy code than we really need to.
By incremental testing, you mean it can detect what has changed since the last run? And if one of the libraries, one of the deep down dependencies has changed, then everything that depended on that gets tested?
Yep.
Otherwise, if it's just a Leaf application, then it just does that?
Yeah. So if you change code in what it calls a base, which is essentially sort of an application or a service, if that's the only change, that's the only code that'll get tested. If you've changed a component that's widely reused, it'll retest everything that depends on it. And so it'll figure out which projects might be affected by a change, because it also separates out kind of the service or application code from the reusable components from the artifacts you build. And the artifacts you build are considered to be projects. And so each project could have different dependencies. And so it knows how to build the environment to run the tests for those. And it will only test a project that depends on something that has actually changed since the last test run, or the last stable release, or whatever you tell it. We actually have a tag we put in Git every time our CI runs. And that gets updated every time we do a build of our master branch. And so any testing done on other branches essentially is going to only test things that are changed relative to that, because the CI does a merge, and then anything that's changed relative will get tested.
Does it ask Git essentially? Does it ask Git to know what the differences are? And
yeah.
So that it knows what paths changed, and therefore.
Yeah. And so you can, while you're developing, you can have your own stable username tag, and you can just say, well, run tests since that stable tag changed.
Oh, wow.
And so, you just periodically update your stable tag whenever you want, and you can run tests that have only changed on your machine, or you can run tests that have changed across the builds, or you can run tests since a particular version, and so on.
But all of that only can work if you follow the organizing principle?
Yes, because it relies on the naming conventions and the code organization to detect the dependencies, because it actually looks at the code, and because of the structure, it can tell whether a require in a namespace is using part of another component. And so it can tell based on the require namespace tree whether things have changed. And so that's how it does it. It looks at what source has changed, what components is that part of, what's the dependency tree in terms of requires, and therefore which projects depend on those namespaces. And it's pretty fast for doing that, considering how much work it's doing.
Even in your 40,000 plus lines.
Mm-hmm.
So it sounds like you're able to migrate over it somewhat incrementally. Like you didn't have to rewrite everything to Polylith.
No, and in fact, the Polylith book has an example and says, okay, if you have a big blob of code that is your application, put it in a base and create a project. And the project says, this is how you build this application. And here's the main namespace, and it's over here. And so that's kind of the minimum thing you need to do to migrate to Polylith.
And so a base is like an application, like
application
what you would
or
say
service.
application.
Yeah. So it's generally got a main. It's going to be either a CLI program or it's a web server program or something like that.
Okay.
And all of ours are either web server programs or CLI tools. And then you gradually start pulling code out of that into what it calls components. And that's where you have to follow the fairly sort of strict naming, because it uses a convention where you have a top level namespace dot component name dot interface, which is the set of public functions that component exposes. And then you have any other number of namespaces, which are the implementation. And in general, the interface namespace will always just delegate to the implementation namespaces.
Something hidden back behind it.
Yeah, so it's just in another namespace. And the poly tool will actually say, oh, you know, you're trying to use the implementation of another component, you should use the interface instead. And so that's something that seems like quite a bit of ceremony and quite a bit of duplication and boilerplate, because all of your implementation functions have to be defined in the interface, the things you're exposing.
Mm-hmm.
So, you know, even if you have functions that are sort of just 1 or 2 lines, you're still going to have an interface namespace with everything in it that delegates to the implementation namespace.
Right.
You don't really have to have the implementation namespace. You could have the implementations, these functions in the interface, but, you know, why would you do that? But then the nice thing is, if you follow this pattern, you can have swappable implementations where you have 2 components that have different names, but have the same interface layout. And so they expose exactly the same, they have the same namespace, and they have the exact same set of functions. And the poly tool will actually check that as well.
Okay.
So if
They'll
you say,
you can mark them as like these are equivalent or these are swappable, so it'll know to check.
You put them in profiles. So you can say, well, I've got my development project, and then I'm going to use this as default profile, which has these implementations in it. And then I might have another profile that has these other implementations. And because it knows that the component name has a different interface name, it's able to do some checking on that and say, well, here's the other component that has that interface, and they should match.
Gotcha. And so how would you swap out different implementations? Would you just, your base would just require the other?
Oh, well, you require the same namespace in either case, because you're going to require something like, I mean, in our case, ws.http client.interface. But that comes from one of 2 different components,
It
even
depends
though
on
the
what's in the
interface
class
is
path.
identical.
It depends on what you.
It depends on what you, yeah, on the dependencies, because what you actually do in your project is you say, well, this project has a local root dependency on, say, the HTTP client Hato brick, and this one has a dependency on the HTTP client HTTP kit brick. But the interfaces are identical, and then the code could use either independently.
The same namespace name in both of them.
Yes. And that's kind of the trick it uses. So you have multiple identical interfaces with different implementations, but because the interfaces are the only things that are callable and they're identical, you can swap them in and out from any other code. And it's all at assembly time. So your development project specifies the default set of implementations, and then any individual project you're building specifies the specific implementations it needs. So that's how we're able to build some projects with HTTP-Kit and some with Hato and some with Jetty and some with HTTP-Kit server and so on.
Yeah, this seems somewhat similar to the thing we were talking about before about having the logging interface and having different implementations and things before.
Yeah.
Is the concern, I think this is fine for things that are used enough that it becomes standard, but does this sort of work against being like in a more dynamic environment? Does it become more static as a result, or am I not looking at it the right way?
Well, because the interfaces are identical and the implementation's the different part, you kind of have to pick one at build time. So it's really about providing different implementations of things for different services that need them. But at runtime, you would use any other technique you wanted for swappable stuff. So protocols, multi-methods, all of that stuff can be done with Polylith as well. And I mean, we use component extensively, and we have mock components for things that we swap in at runtime for testing.
Yeah.
And none of that is impacted by Polylith in any way.
Do you build those with? Do you have test bricks then? Or
yeah,
not?
each component has its own tests, and the test environment is figured out by the polytest tool, where what it does is it looks at projects that need testing based on the dependency trees. And then it looks at the actual dependencies that that project would have, which could be different versions of libraries to other projects. And then it will figure out all of the test paths together from all of those components and the project, and assemble that as the command to run the test runner. And it'll say, here are all the paths where you'll find the source, here's where you'll find the tests. These are the namespaces you need to run tests on.
Oh, wow. So it can run across all of your libraries and applications.
Yeah, it uses
all in one.
It uses class loader isolation. So it does a lot of work to set up isolated class loaders that each have their own independent environment. So that was always kind of one of the really good things about boot, was that you could have pods, which were isolated class loaders. But there were some weird things with the way boot did that. And Polylith, I haven't had any problems with the way it does class loader isolation for testing so far.
Is there some perhaps practical limit to how small your components or bricks or whatever they're called be?
No, I think most of ours have anything from a couple of functions up to a couple of dozen.
Okay.
One of the things we've found is because it requires you to name everything and it's a flat component namespace that has a very structured top-level namespace component name interface pattern, you start to think a lot harder about what you call these things. And so we as a team have found ourselves discussing in much more depth than we used to what we should name a given component. And that, I think, is a benefit that isn't associated with anything tangible like code, but in the ability to look in the components folder and go, yes, I know what each of these things does because we've talked about it and they have obvious long names.
So if I rephrase that, you're saying that the conventions that I used and followed across the board gives you the benefits of looking. So when you look at something new, you say, because of the convention, this is what it is.
Yeah, and you can see just from the namespace, you know exactly where the code will be. You can see just looking in a piece of legacy code, you can tell which are the Polylith pieces it depends on and which are the legacy pieces, because the pattern
okay.
of namespace naming is different.
I see.
And so, as you're working on the code, and we have some unfortunate big blobs of code that kind of grew and grew and have a lot more code in them than they should. And when we go into something like that and we say, well, I need these 3 functions because they relate to this particular aspect of it. So I'm going to put them in a component, and that'll make me think about what do I call this component as opposed to any other piece of this big legacy ball of mud. And then that chooses the name of the namespace for you. And then you look at it and say, well, these function names aren't very good. So while I'm refactoring, I'm going to change the name of them to make much more sense with the new component name I have. So it really does make you think about naming a lot more than I think just, regular writing code does. Unless you work on a team that is very, very hep on naming things and has discussions about how to name pretty much everything.
Naming is one of the hard problems in computer
Naming is
science, right?
hard. Yeah, naming is hard.
I
Does
laugh
it-
because my
Go ahead.
oh sorry, I just say I laughed because my previous job had hours long naming sessions, so I definitely
Okay.
sympathize with that. And I mean they're usually beneficial.
Yeah.
Usually it's because there's like naming conventions that we have, and there's something that falls in the gap, and it's like we have to figure out which side it goes on, or if it's a new type. Like that's where a lot of but it's good to have those discussions because then you benefit from a good name forever,
Yeah.
Does your project have to be a certain size or complexity before you can see the benefits of Polylith, or can you do that for a starting project?
Yes, it probably does need to have a certain size. I think Polylith solves a problem that you don't really get into until you've got multiple project artifacts being built out of a mono repo, and you're trying to share code between them and manage different sets of dependencies. So I think the minimum project size you need is a repo that builds more than one artifact and potentially has different dependencies between them. And as soon as you get to that point, then Polylith can start to help. And kind of one of the things I've been thinking of, but it would potentially be, well, I could do it without breaking things, is to actually combine HoneySQL and Next.jDBC into a single repo. Because one of the benefits for me would be to make end-to-end testing across multiple databases much easier. And I could still build jar files for libraries from that, and keep the original namespaces. It would be a bit of work, but it's definitely possible because you can put the namespaces in the project itself, so they exist only as part of the build. But if they delegated to Polylith components, all the guts and the implementation would be in Polylith.
So a project can be a base, like an application, but can a project just be a library, or a component?
Well, a project is how you build it and can have additional tests and could have additional source code. So you could put a shell set of namespaces in a project that provided a particular API, for want of a better word, for a library that then delegated to an implementation that was pure Polylith. You just have to figure out how to actually, when you build the library, to make sure you build all of the source, all of the Polylith code would have to come in as well. Not PolyTool itself, but the structured components and so on.
The actual implementation.
Yeah. So, it's definitely aimed at building applications rather than libraries. Because if you're sharing namespaces across libraries, obviously you have the issue that if multiple libraries of yours get used by someone,
Yeah.
they potentially have the same namespace in multiple places, which if it's different versions, you do not want.
Yeah, I mean, it definitely seems like it's pretty squarely at people that, or teams that have shared libraries among several applications that they support.
Yeah.
And I mean, at my previous job, we had several applications and we had libraries, and we just used depth-cdn with local root. We didn't have cross testing. But I think from what we had to what Polylith has, I think it's would have been a pretty straightforward shift, because we already were used to that that structure.
Yeah. Yeah. And in our old code, we weren't very good at namespace structuring, and we got better at it over time. And we did at some point adopt essentially a common top namespace and a structure underneath. And so migrating those things to Polylith has proved much easier. We have some pieces that I'm looking at, and I'm like, oh, it's going to be a bit painful to move because it has a terrible namespace structure. And you end up having to rename a lot of namespaces to conform to the structure.
This would be namespaces in a base, like an application.
Yeah, if you have a legacy system with a fair bit of code that doesn't sort of naturally follow some sort of common top namespace dot subsection, then moving it into Polylith is going to require a lot of renaming.
Gotcha.
Because everything in Polylith, whether it's a base or a component, follows that top namespace dot name of thing dot file. So you always have those segments at the beginning.
Those always push in.
Yeah.
Gotcha.
So, for example, we have an admin base, which is our admin web app. And so the top namespace for that is ws.admin.web. And luckily, it was almost that in our legacy structure. So the renaming was automatic and not too painful, but was still fairly expansive.
Prefixes, right?
Yeah, yeah. And some of our apps just happen to follow that ws.appname.subnamespace stuff very, very closely. Those will be easy to move into a base in Polylith.
So your base and your components, they have to share a top level namespace?
Yes. So you have a common top level namespace across your entire repo.
Oh, interesting. Because
So
I always had at my previous job, we had all the libs had lib dot at the top,
right,
and our apps all had app dot at the top. Because so you could see. So this would just have to push down to like company name dot lib dot and company name dot app.
Yeah.
Like it could be pushing that at the top. Gotcha.
Yeah. Yeah. So, it does require an extra bit of structure there. But it does make for a nice, consistent code base. And especially if you're migrating, because that alone can tell you whether you've migrated things or not.
I mean, one of the big benefits of just using a monorepo at all is that you can have commits that go across a library and an app. That was a huge benefit. Before we had multiple repos, every thing was an independent repo, and so you'd have like, I've got 3 PRs for this change, and across 3 different repos. It was just a nightmare. So monorepo already was a win too.
Yeah, and we've got, I mean, when we started the Polylith migration, I think we already had 40 sub-projects building about a dozen artifacts. And now, oh, I don't have a terminal open. Let me go open a terminal. 2, 3. I will expand this up. Why don't I actually just share screen?
Oh, that'd be wonderful. We are recording. Remember that.
Yeah.
Okay.
Screen, yeah, sure. Okay, so let's go to here. So you should see a big terminal window.
We do.
I'm firing up
mpoly.
Yep, -m poly shell. So here's Polylith, and this is the interactive shell it has. So if we do info lines code, it has word completion on that. And then this will analyze the entire code base. Let me,
Oh, wow.
yeah, no.
I love tables. Good.
So let me scroll back up. Okay, so here we have 20 projects. So we build 20 artifacts from this. There are 14 bases. So we have 14 applications that we have converted to Polylith so far. So you can see that we have 6 artifacts we build that don't have corresponding projects. We have 46 different component implementations and 44 interfaces. So we have 2 swappable components. And then it lists the active profile default.
Sean, what would be an example of those 6 that are projects but not bases?
Well, I can list down here. Let's see, Activator has been brought across to be a brick. API has not yet. So this is our main REST API. So there's a project that says how to build our main REST API, but we don't have a corresponding base for it. These are the bases down here. So
because it
that
hasn't
mean
been
you
moved
haven't-
over to Polylith.
You haven't extracted the base out of the project yet? Is that-
correct.
Okay.
So our Polylith project file just says, go depend on this legacy subproject.
The whole thing.
Yeah. And it in turn has its own local root dependencies. But for the Activator project, we have an Activator CLI base. So that tells us it's a command line interface. And that base has most of the code from main down to the reusable parts. And then it in turn depends on a whole bunch of other things. So we can actually look and see, here is a dependency, Activator project, which depends on the Activator CLI, and it also depends on the Activator brick, and the billing data brick, and the billing SDK brick, and the billing specs, and the configuration, and data sources, and exceptions, host services, the Hato client, our client response library, safe coercions library we have. And so those are the things that the Activator project depends on when we do a build.
What real quick, what's a brick? Is a brick a component or a base?
Yes. So brick is it's the Lego idea. So you take bricks and you build them together into something else. And so these down the bottom are the things that we have migrated over as applications so far. But the projects includes all the things we haven't migrated yet. And then these are all the actual components we've extracted from our existing code, and all of the things that depend on them. So you'll see almost everything depends on the Hato client there.
Yeah.
But here's the HTTP kit client. And let's see, right now, there's an HTTP kit profile, which is what this is. These are the profiles. And we use that for one of our legacy apps. So the legacy app is built kind of separately to this. It's so legacy. And it specifically uses the HTTP kit profile, which brings in the HTTP kit component. And so all of the HTTP client requests it makes use that library instead of Hato. And then the only other thing that we have multiple swappable implementations is our I18N library. Normally, it does everything off a database, but we have a preview app, which is a very small, lightweight app that our UX designer uses. And that gets packaged up as a jar, and he runs it locally. And the I18N preview component pulls all of the translated resources out of a JSON file instead of the database. So he doesn't need a database running. He doesn't need any of the environment configuration files or anything like that. And so at the moment, everything's got a star by it because it thinks pretty much everything has changed since I did a stable build on this machine. And that's because this is a brand new machine and the stable tag is on a branch, which is the only thing I've worked on since I set this development environment up about 6 hours ago. So, but you can do, let's see, if I did depths, this will probably be unreadable without shrinking it down. Oh no, it's not too bad. So this is all of the actual interdependencies between bricks. And you'll see it's fairly sparse at the moment because we have migrated from the bottom up in our legacy code base. And so there's a lot of legacy code that is actually the dependencies, and the bricks themselves don't generally depend on each other too much. But this will change. As this matrix fills out more, I'm going to send a snapshot over to the Polylith team. And they're probably going to put it in one of their use cases, their case studies rather. But you can see that the bases do depend on a lot of components. So the admin base here depends on almost every component we have so far. And this is our internal facing admin app that allows member services to deal with billing issues and everything else to do with member profiles and member accounts.
What's the T versus X?
T for test, so it's a test only dependency. X is a source dependency. So the other thing you saw on the first matrix was ST and X, and X indicates that it would be run if you said run the tests. So this is, let's see if I can wind this down. Oh, there you go. Okay. So this is, this is a list of every third-party library we use, broken down by, oh, it's still not readable at the top, but broken down by brick and base. And you'll see some of the libraries are widely used, like tools logging. And then you'll find some of the others. Oh, that's only used in a project, so that's a weird thing. Let's see. So the Cognitect AWS is only used by our uploader brick. All of our build tools and CI pipeline and all of our machinery is also inside the Polylith repo. And so when we build artifacts, we have a little piece of Clojure code that uploads them to S3. And so we use the Cognitect library for that. But it tells you the version. If you end up with bricks that different bricks using different versions of the same library, it will list each of the different versions and show you which bricks use which. So when I look through this, I always hope to see no duplicates in any of that.
Yeah, definitely.
It tells you how big the library is, where it got it from, whether it's a Maven coordinate or a Git coordinate. So you'll see here, there's one Git that we use, which is an updated version of Clojure Java time. And then here's all of our internal legacy subprojects that we haven't converted yet, which are dependencies of some of the bricks. And so we give them world single / coordinate names in our deps EDN files.
Oh, those are all the legacy not yet converted yet.
Yeah, this is the legacy subprojects that we're still pulling apart. So it's definitely a work in progress. And like I say, info lock, we do that.
Super wonderful to be able to go to live in both worlds because you can't just stop for months to transition.
Yeah. So I mean, when we started, it was a case of, well, here's one of our apps, just it follows the namespace convention. Let's just put it in a base and add in projects for each of the artifacts we build. And they just specify the top level namespace in a legacy subproject, and then we're done. And so switching over to building everything from Polylith was a couple of hours work. And then the ongoing work to migrate all the code to it is just whenever you work on a piece of code, if you think it needs to be brought out to a component, go ahead and do it.
What were the things that sort of convinced you to try Polylith? What sort of problem that you were facing that you thought it could help you with?
Part of it was naming and structure. What really made me want to start the migration was looking over our code base and looking at the namespaces and thinking, wow, we messed up on some of our old legacy code. We have namespaces that have far too many functions in that are doing too many things. We've ended up mixing, for example, admin related code with member facing code in terms of, how much the system knows about things and what the rules are. Because, well, we had a site namespace that was everything to do with sites and metadata about sites, websites. And it gradually just grew all of the functionality across everything that needed to interact with sites. And what we should have done right from the early days was split that out into, well, what metadata about a site does, say, our search engine side of things need. What's common across everything? What's admin only? And, for something like that, modifying the site metadata is an admin only function. So nothing that modifies site data should ever have been in the shared component. But that's easy to say with hindsight. When you're working on something and it's like, oh, here's all the site related stuff. It's got all the functions I need to call. They're all private functions. I'll just add this new public function in here and call the private functions, and then I'm done. And so teasing apart some of those bigger, older pieces is going to be, real interesting work.
And from your experience now, what would you say are any of the problems you've run into, or
yeah, I mean, the naming convention and the sort of the delegation from interfaces to implementations feels a bit painful. I've gotten into a bit of a flow with it now where I tend to copy code into the interface, get everything working again with the renames, and then refactor the implementations down into the implementation namespaces. So that's a better flow for me. It feels like you're duplicating a lot of stuff, but if you start to really get into the mindset, it gives you the opportunity, for example, to have a docstring in the interface that is aimed at people who want to use that component. And then the docstring for the same function in the implementation can actually talk about why it's implemented the way it is and considerations about maintaining and changing the implementation. So having multiple docstrings for different audiences has actually quite a benefit, but it takes you a while to get to the point where you start thinking about that and not just, oh God, I'm duplicating function signatures everywhere. So there's that. The other thing that I've run into, and it's hard to nail down as an actual bug, is if you have project-based test fixtures, which is the sort of the setup and tear down for an entire project suite set of tests, which is something that the test runners don't generally give you. If you have a missing dependency that your project-based test fixture needs, the tool doesn't spot it, and the errors you get when you try to run tests can be a bit cryptic. And so it can be a little hard to figure out that you're missing a test dependency sometimes. But otherwise, the Polylith team has been really responsive to anything that's cropped up. And they're really receptive to feedback and looking at ways to make Polylith easier for people to use.
Seems that are there, like, it's other than the cases that you mentioned about Hato and the HTTP client, are the implementation and the interfaces essentially one-to-one mapping?
Often, yes. Out of the 46 components we have, that's 46 implementations. 44 of those, let's see. 4 of those implementations match 2 interfaces. So 42 components have a one-to-one mapping with the interface. And it's only the 2 components so far that we've needed to have different. But one of the other benefits we got from separating out the application code from the project artifact build and description is we had a situation where almost all of our code was fine with an updated version of a library, but one project required an older version of the library to work. And so being able to override that one project's dependency to force the older version, it was very, very easy with Polylith, because you just go into that project's directory and its deps file, and straight away you've got the control over just what you're building there, and you don't have to touch anything else, and that will allow other apps to use whatever version of it they naturally end up using. And so if I was to go to let's see, Clojure. So we have kind of a terrifying number of deps EDN files. But you'll see that all of the bases have deps EDN files. All of the projects have deps EDN files. And in fact, then down here, all of the components have deps EDN files. So a component and a base specify their external dependencies, third-party libraries, but they don't specify their dependencies within the repo. The only things that specify that are the projects, which say, when you build this artifact, these are the bricks you use, and the development project, which is how you run your REPL. And so for the development project, you specify all of the components along with, for the swappable implementations, which one is the default. So let's see if I...
What happens is, does the Poly tool help you when you have a project that depends on a component that transitively depends on another component, but you don't include it in your project?
Yes, it will spot and say
check,
you have a missing component. So I mean, if I fire up VS Code, and hopefully we don't have too much code available.
Are the implementation, sorry, the interface and the implementation, those are just in the same component?
Yes.
Like,
so
they don't, there's not like a separate interface tree. It's just defined but via convention.
Yeah.
.interface or whatever.
So for example, if we look in our data sources, it has an interface. Oh, let's put that up here. Let's move that around a bit. So here's our data sources component. It has a method, a function to destroy a data source, whether it's the system's been initialized, a pooled data source, and probe, which is our new relic thing, and this goes in and does analytics on data sources. How you build your data source component, this is our component model, and then there's this nasty legacy accessor. Pay no attention to that. But you'll see in here that some of this uses pooling as the namespace for the implementation, and most of it uses impl. So you can split the implementation into as many namespaces as you want. And then inside the implementation,
that ends up being a component, like a Stuart Sierra component.
This happens to be because we've used component to build this. So if I drop down to, let's see, here we go. So here's our Stuart. Yeah, here's lifecycle. And so this is where we build the database component, which has all of our different database connection pools in. And so it builds nice and idempotently all these different connection pools and shuts them down. And then system is the exposed function that creates that component. So the fact that it's component isn't really exposed to anything. except for the code in the base, which is the application code that builds it.
It's using
So
it.
yeah,
Right.
so your Stuart Sierra components, you put them in a brick, you assemble them in a base, just like you would with regular code, and it has no impact on how Polylith interacts with any of this. If I go to projects, let's see, scroll down to projects, let's just arbitrarily pick one of these. If I take caching out of this project and I go back to Polylith and I say check, there we go. So it says, why is that not doing this? Come on. Oh, there we go. Now you can read it. Missing components in the publisher project for these interfaces. So it tells you straight away that you can't build this project without providing a dependency for that. And so, for example, in our preview component, you'll see here we have the preview version of the I18N component rather than the full version. And so each project can specify which implementation it needs.
In this, by just specifying a deps-EDN dependency. So
Just
it's like
by having a deps.
it's using the natural tooling for dependencies. It's not trying
Yes.
to make its own. It's
Yeah,
just
it's
conventions
completely natural.
and then being able to check those.
Yeah,
Huh.
and so if I was to go into the I18N preview component and change something in its implementation, let's see, let's go back. Components, I18N preview, source interface. Let's go change the name of this to foo, and then go back to Polylith and ask it to check. Function in the I18N component is also defined in I18N preview, but with a different parameter list: countries foo, countries lang. So
not even number of, it's even the name of
the names.
Wow.
Because when you're dealing with the interface, the code assist you're going to get is going to have the arg lists with all of the names in. So you do want them the same, even if the implementations are going to be different. Wow. So this gives you a lot of sort of confidence that you've got everything lined up, matching, and all of your dependencies are in place. Like I say, aside from some of the test dependencies if you're using project-based fixtures. And then probably the other thing that's worth looking at is at the top level, you have a workspace EDN file. And do you want me to make that a bit bigger?
No, no, I think it looks good.
There we go.
For at least for me. Wow.
And so this there's our top namespace, WS. It's using Git. I think it does support other things, but Git is the default here. If you create a new component, whether it's automatically added, because by default, it used to do a Git add and a Git commit for you. And now it doesn't do that by default, so I don't actually need that there, but you can have it automatically add new components to Git for you. And it will create a whole sort of file tree with test stubs and namespaces and everything else.
Is that something you can run at the poly prompt? You like new component something?
Yeah.
Oh wow. Okay. So it's got a little bit of like the Rails style, like making a new thing.
If I said create me a new component whose name is Los Angeles, and so it goes off, creates all the files, says remember to add the paths or local dependency to your dev and project deps. It doesn't modify those for you because you might want to do different implementations or set them up differently. But what it has now done is, if I go back to here and look in the components again, we will now see a Los Angeles tree here with a default resources, source interface, which is just an empty namespace, a test, which is a dummy, which will pass for the interface, and a deps EDN file.
That it said add it to your dev Is that the top level depth EDN that's at the very top
Yes.
of your?
So
Okay,
right
gotcha.
at the top of the tree, you have a huge deps EDN file that has your dev alias, which is your sort of everything in the Polylith world. And so here's all our bases, here's all of our components. And so I would add that in here as Poly Los Angeles with a local root. And then I would add, oh, and here's the sort of common third party dependencies for working in the REPL. So we specify which version of the MySQL connector and which version of Log4j we use. And then here's the profile. So by default, we'll use HTTP client Hato and the main I18N component. If we build the preview app, we'll use the Hato client, but we'll use the preview version of I18N. And then the test dependency, which says, here's how we run tests. This is legacy component. And then there's expectations, which is our preferred testing library and test check. And then here's all of the paths to test folders for the bases and then the components. So if Los Angeles test existed and had anything in, I'd put it in here as well.
So when you run a dev REPL, it has all of the source from all of the components and all of the bases.
Yes. So when I start the REPL, I start it with the dev test aliases, plus a whole bunch of other stuff. In fact,
So running nREPL is like an additional.
Yeah, I mean,
Oh, yeah.
this is actually my command. Let's see, how do I wrap? What will word view wrap? AZ. Okay. So this is my REPL start command. So I have a -J option to specify the configuration file for logging, the local operation. I specify the build alias so that I can work on the build file in my REPL. The dev alias, the test alias, that's Polylith, and then everything and runner is our legacy sub project stuff. Adlibs comes from my .clojure file to use the adlibs branch of TDA, so I can add new dependencies to a live running REPL. Jedi time is a library that provides datafy and nav for all of the Java time types. nREPL brings in nREPL, obviously. And in fact runs the nREPL command line to start it. Portal, which I use for all my data viewing. Reflect is a Stuart Halloway library that provides reflection on namespaces and I think a few other things that's nice and useful. And then my dev REPL alias, which is what actually figures out whether to start a socket REPL or an nREPL, or whether you've got Rebel readline on the class path, in which case it will start that instead. And I think it does a bunch of customization I think that's where I do the customization that if you have tools logging on the path and portal, it wires up all of the tools logging stuff to come into portal automatically. So every log message gets tapped into portal. So this would be 2 aliases shorter if we didn't have any legacy code, because everything in runner, that should say, is our legacy source and test, and dev test is the Polylith source and test. But it is nice being able to have access to the whole repo, all in your editor, and in your REPL to be able to fire up any of the artifacts just by, whatever rich comment form you've got in the apps. If I was to bring up the admin and drop to, let's just quickly go down to the bottom. So here's my rich comment form that says, define an admin app, which component start build system on a port, and component stop. And so if I evaluate this file and then evaluate that, I've got my admin app up and running, and I can visit it in a browser and modify all the code live from the REPL and then shut it down when I feel like.
I can understand the aversion to using the refresh whatever mentality, because I mean, I couldn't imagine how long it would take to search all those namespaces and refresh them all.
Yeah, it's and the trouble is that if you do that and it breaks, if refresh breaks your setup for some reason, which it does occasionally for people, then you've got to quit and restart your REPL anyway.
Yeah.
And as I've said in the past, I normally have my REPL running for days or even weeks. Although we'll see how long it lasts on Windows. On the Mac, I could leave everything running, and I'm not sure yet whether I can leave Docker and WSL running indefinitely without problems. So we'll see. So is there anything else you'd like to see about it?
I mean, as we were talking about it earlier, Polylith, I was like, we really wish we could go through an application and actually point at files and see stuff. So thank you for sharing. It's very helpful to see it in use, because it anchors a lot of these concepts. They're a little abstract if you don't have that.
Yeah, it's definitely one of the difficulties with Polylith, that to see the value, you kind of have to use it. And it can seem a bit painful at first because of the interface implementation duplication.
And now I can look at the example app, and a lot of the files now, oh, that's the workspace file, or that's the IC. Okay, now now at least I know I've seen one before, and then I can look at this more in depth at my leisure.
Yeah, and doing poly info tells you a lot about the real world app. It tells you how it's structured. It tells you what the dependencies are. It tells you what artifacts it builds, and so on. So you can go into any Polylith code base and just run the tool and say, well, tell me what it looks like. Tell me what libraries it uses. Tell me what the dependencies are. And I'm pretty sure there's a help function as well, if I remember rightly. Here we go. And so,
wow.
Yeah. And it's also kind of meta, because you can go in and look at the workspace data structure. And so if I did workspace get components, keys, I haven't tried this. So you get a printout of a vector that has the strings for all of the component names that are in the app. So you can introspect the whole workspace within Polylith itself.
I think there are, I mean, it feels like there's been a lot of people asking questions about, how do I structure a real world app? And, the component and those family of libraries are how you would structure an individual app. And Polylith seems like it's the next level of, now I have multiple apps and I want to share code between them.
Yeah.
How can I do it in a way that, because this is, I mean, you don't have, 20 applications and 40 libraries and just have one person. You have to be able to have more than one person look at this and not go crazy.
Right.
and so Polylith, especially the introspection, and the fact that it's a common tool, like it's not just World Singles that has this convention. It's
right.
If we went to a different company and they use Polylith too, like the namespace name might be different, but because the convention is so standard, and sounds like it's rather, I mean, you just follow the rules, and then you can switch between them.
Let me see if I can just quickly get to this. That's the high level stuff. Maybe it's in the tools. No, that's this one. Get lost in the documentation. Yeah, I think it's Poly. Introduction. Oh, example systems. Duh. Here we go. So if I go to this, And let's see, yeah, clone. Getting used to a new keyboard.
Well, especially you were on Mac before, and now you're on Windows.
Yeah, and I have a number pad and arrow keys, which I've never had on a keyboard before. So my right hand is always too far to the right. So that's really taking some getting used to. Okay,
Yeah,
so let's see, cat deps, just make sure that it's got poly tool. Yeah, okay, so Clojure -m poly. Let's see if it's got the new version of poly. Shell. And it'll download the world. Oh, Bork Dude's sigh. I wonder what that's in. Okay. Whoa. So yeah, that's using an old version of Poly, so that's not too surprising. Okay, then what I can do is say info. I'll just
the newer version has that shell. Where you
so the new version has the shell and the old version doesn't. I didn't realize it was still using an old version. I've gotten so used to using the shell. And as you can see, I'm using Clojure 1.11, hence all the warnings. Okay, so yeah, the real world app's pretty small. So it's 2 projects, 1 base, 9 interfaces, 9 components. So it has a development project, which is how you run the REPL, and it has the back end, which is the app itself. And so there's not a huge amount in there.
Yeah, getting rid of that Java startup.
Yeah. Again, that's why I run the shell all the time.
Mention it every other meetup just to make sure we're grounded.
Yeah, and so here you can see it's got quite a filled-in dependency grid, and the REST API base uses every component, but even some of the components depend on others. So, you know, comment and article are linked, comment and database, not surprisingly, comment and profile, comment and spec, comment and user, which is test-only dependency. So there you go.
The green article and that uses the vertical, that's the uses the database. Okay.
Yes. Yeah. That's so these are the bricks. These are the things they depend on across here.
Gotcha.
So I am going to have a hard stop in a few minutes. So at this point, I'd like to stop screen sharing.
Okay. Yeah.
Yeah. Thank you, Sean.
Last questions and comments before I do?
No, it's been incredibly helpful because I think I also really appreciate the your sort of distillation and of the benefits and so on. That was very helpful to me, at least.
Cool.
And I found that very
Thank
useful.
You. Yeah, thanks so much for sharing that.
Well, I think I would definitely try. I would definitely. I'm open to. Before I was like I didn't understand. So now I'm like I'm Polylith curious. You know, I see the benefit.
Excellent. Well, the Poly team are very helpful, as are all their users. So you can go find them in the Polylith channel on Slack.
Okay.
Cool.
Well, thank you again.
Yeah. Thanks for driving, Sean.
Yeah.
Really
okay. That was fun.
Yeah.
All righty.
So we'll see you all in the next half of the year.
Yeah, next month. Next half of the year. Oh God,
next
yes.
Quarter, next half.
Oh yeah, don't. Time flies.
Well.
Okay.
All right.
Cool. Well, thank you all.
Bye.
Thank you very much.
Thanks,
see you next month,
Tyson.
folks.
Yeah, thanks again, Sean. See you all next month.
Thank you.